Well, we'd like to welcome everyone to our session today. My name is Corey Allen. I'm a staff technical product manager in the VCPP business group.
Hello, everybody. I'm John Weiss, presenting here with Corey together. I lead the product team at Fortanix.
So we're really happy to be together today to talk to you about enabling data privacy in your VMware Sovereign Cloud using the Fortanix DSM. Of course, as always, we have our disclaimer here. The information being presented, we would be very thankful that you do not share this information out without our consent. And now to our agenda. We're really going to help you try to understand the VMware Sovereign Cloud and what it is. We're going to drill down into a specific piece of that Sovereign Cloud definition, which is the data security and compliance area, and show you some different use cases that you can use in order to secure the data that your customers have and that they really need to protect. And then also we're going to look at the Fortanix Data Security Manager and how it can provide data security in your sovereign clouds. So what's in it for you? Our goal here is to provide you what a sovereign cloud looks like, and then how Fortanix can secure a sovereign cloud. And then of course, what types of encryption is possible with Fortanix. So John, we're really looking forward to seeing what Fortanix can do for us here. Well, let's take a look at the overview, the VMware Sovereign Cloud overview. Just a quick statement here that we see 63% of our customers that are in regulated industries, they really feel that it is important to have a cloud solution that provides complete jurisdictional control and authority over that data.
We're really pleased to be in partnership with Fortanix to offer some of these capabilities regarding jurisdictional control of both data and the keys to the data. Interestingly, we've been seeing a trend recently toward sort of a step back from full globalization and massive data lakes. Traditionally, connectivity has transcended those national boundaries and political barriers, but now we're seeing a lot of local privacy regulations apply, and the motivation for these is really to ensure that the local expectations for citizens on data privacy are being applied in the relevant domain. So whether it's GDPR or some of the US regulations like California's CCPA, right to know, right to delete, right to opt out, we're really seeing a significant demand for increasing sovereignty of key material data and therefore a desire for more control.
Well, that's great. That's great to know, John. Thanks for that. Let's take a look at our sovereign cloud definition as we think about what John mentioned there around data sovereignty. The core proposition is to provide enforcement of that data and then where that data lives. Of course, if possible, we want to be able to extend those data sovereignty protections beyond the immediate platform. But our main goal is to provide secure audited connectivity, even with data transactions and at-rest data, where we have different data classifications being resident, sovereign, and even non-sovereign domains. So this definition is continually evolving. And of course, depending on where that data lives, in which jurisdiction it resides, really the sovereign cloud definition can change and is often, or all the time actually, dictated by the customer that owns the data. So let's look at our sovereign cloud framework. When we think about a sovereign cloud there in the very center sphere, that expected product, we're looking at a VCF or VMware Cloud Foundation platform as a base, and we're going to build out from there. The goal here is to set up the environment in such a way where we can maintain our data sovereignty and jurisdictional control. And then as you move out to that next sphere, we have the three areas of augmentation, which is data access and integrity, data security and compliance, and then data independence and interoperability. Now, of course, as providers, we are hoping to help you find a way to differentiate yourself from the rest of the field. So by providing these three areas, that really helps you to stand apart from other providers in this space. And then, of course, that last sphere, that optional area that we can continue to extend a sovereign cloud by using data innovation analytics, so machine learning, AI, and even developer tools, developer-ready tools. So as we dig into that data security and compliance section of our sovereign cloud definition, we think about these 5 areas that are critical to maintaining that data security and being in compliance with whatever regulations are in place in your area, your jurisdiction. So of course, security and controls are key, where we think about the people, the process, the technology, and of course, access management. Certifications really are dictated to you as a provider by your customer. What do they need you to have in place in order to be able to serve them up the sovereign cloud offering that they require? So it could be, if you're in the United States, a FedRAMP, or even HIPAA is of course universal, and then EU data protection, and even TRIMS 2 comes into play when we're dealing with our customers' data and what is available to others. Now, of course, auditing is a key piece as well. And as is stated here, it should be done annually and preferably by a third party. We want someone who is outside of our organizations as providers to be able to audit our sovereign cloud environments and provide those reports to our customers and ourselves, either for remediation or for follow-up in some way. Now, our security posture is going to be key because the goal is all about protecting that data. So do we use microsegmentation? We isolate our resident domain, and of course, making sure that application and data isolation protocols are in place as well. But today we really want to focus on the encryption space. John, can you help us with what we're going to talk about here?
Right, we'll be going into how you can encrypt both your critical workloads running on VMware as well as your databases, and even secrets management and things like Tanzu, if any of you are using that. Also, we'll be discussing how you can use hardware-backed security, which is a higher level of certification and compliance available to you, and also the ability to ensure that the customer can hold their own keys and be confident that the data is encrypted through its entire life cycle.
Yeah, that's a key point. Our main goal here is to help you understand how your customers can bring their own keys to the environment that you provide, but there are other options for you as well. So we're really excited to show you how this works. But first, let's take a look at some sovereign security boundaries. When you think about where you as a cloud provider might need to sit or operate, we can see this layered approach, and where a cloud provider would definitely live there in the physical security and perimeter and network security layers. Those are definitely in your wheelhouse to manage and take care of for your customers. And a sovereign cloud requires physical security to all of the hardware. No one should be able to have access to this physical hardware that is providing the sovereign cloud offering without proper certification and security measures being checked out. Now, as we move into this lower black triangle, we see where a customer would most likely manage their own endpoints, their application security, data security, and even their mission critical assets. It doesn't mean that a cloud provider wouldn't maybe help their customers in some way manage these areas if they were asked to do so. But in a sovereign cloud environment, this is typically where you would see the roles being laid out. And of course, on the bottom right and left area, we see that it could be co-managed, the policy management and monitoring and response activities. So keep those in mind as we talk through the rest of this discussion today. When we look at a conceptual model, we again see the cloud provider is out in that outer rim there where it's layered or labeled, the rest of the world. When we think about that area of access, we know that there is limited access into a sovereign cloud. It has to go through very controlled processes and protocols and policies to make sure that the data is secure. So as you would have access into the sovereign domain or the sovereign boundary to manage all of the different services you see laid out here. Specifically, we'll be talking about the KMS service, our data privacy there as well. We consider that a cloud provider might manage the infrastructure and the health of these services, but ultimately it's up to the customer to provide the security policies that would be implemented for their specific environment. And then the resident domain being the most central piece there, internal to everything else, it doesn't have access to the outside world. It only talks to the sovereign domain, which surrounds it, or a neighboring resident domain. And again, that connectivity has to be specifically allowed, as we would want to make sure all of our applications and data is isolated from unnecessary access. So this is just a conceptual look at where things might lay as far as the services that are offered.
Right, and we'll be talking about how VMware sovereign cloud providers can also offer those key management services that have the hardware-backed security, either at the level of the resident domain or as a centralized service at the level of the sovereign domain for multiple resident domains. There's a deployment choice, and everything we're presenting today is really approved and compliant architecture that VMware and Fortanix have offered within this framework.
Yes, very, very good. Okay. So let's now take a look at our sovereign cloud provider use cases. We're going to go through 3 use cases that help us to understand where you might deploy the Fortanix HSM appliances and how they might be used in your environments. But remember, the context of our use cases here are specific to a private, dedicated cloud offering to your customers. So the base workload, the base infrastructure would be the VCF or VMware Cloud Foundation platform. And then on top of that, you would have isolated customer instances for their sovereign cloud entities. So our first use case here, we can see that we have 2 data centers laid out per the sovereign cloud provider criteria that is required to have 2 data centers up and running in the same jurisdiction as where the data would reside. And then the customer would bring their own Fortanix appliances into the mix over that IPsec VPN connection, and it would manage the secrets and the keys for those virtual workloads. John, what do you think about these appliances and how this connectivity would work?
So yeah, this particular use case, and we'll be presenting 3 of them, has to do with, as Corey noted, when the customer already says, hey, look, I've already got an investment in Fortanix hardware security modules, and or I want to manage those centrally in, let's say, their own estate. And you see the purple stack of 3 boxes there. 3 is not a random number there. Given the critical nature of the kind of cryptography services that we're providing, we always offer triple redundancy. So those are always deployed in multiples of 3 like that. And you see the key there indicating that those keys are contained with the root of trust that is there with the customer's existing deployment of Fortanix. And then there is actually a authenticated secure IPsec VPN session that is established to the private protected network, which ultimately enables the customer to keep, if they wish, they can create non-exportable keys that are extremely secure, that actually never leave the hardware boundary of those tamper-resistant FIP certified modules. And you see the little locks down in the virtual workloads that are taking advantage of that encryption. So this is the first approved deployment architecture.
Yeah, definitely. We're really looking forward to seeing how this might work out in the real world where customers can bring their own keys in this manner, housing those appliances at their own site, but still connecting to the sovereign cloud offering that you provide them. Our next use case is a little bit different, where we move that cluster of Fortanix appliances into your data centers. So this use case is where you as a sovereign cloud provider would provision this Fortanix cluster into the private cloud or dedicated private cloud that you're offering, that you're building for your sovereign cloud customer. And as you note, we're splitting this cluster up to stretch across both domains or both data centers for high availability and for resiliency, but as well as we want to maintain services in both locations as workloads may move back and forth depending on where they live.
Exactly right. So here again, we see those little purple pictures in the middle where we've got two boxes on one side, one on the other. It could be different multiples, but the point here is that for high availability and redundancy, we would have a redundant cluster that the VCF provider is offering across the data centers, but dedicated to one customer. So what you're seeing here is essentially that the Fortanix Data Security Manager and the hardware back appliances are being placed within the sovereign cloud boundary to protect the virtual workloads with strong encryption. And the key material in these cases never leaves the appliances.
Yeah, and John, you mentioned it could be multiples of 3. So are you saying that really a minimum of 3 is required here, but it could be more?
That's right. And for scalability reasons, the workload could be, substantial and could require, a lot of appliances, but this is sort of the minimal deployment you're showing, really on the left, we put 2 in one in the other data center. And so there is this sort of multi-site redundancy that's inherent in this architecture.
Oh, great. That's good to know. Okay. All right, let's look at our third use case. And this is a little bit of a change here in what we first offered in our first 2 use cases. This is where you as a sovereign cloud provider would be managing this cluster or this Fortanix cluster for multiple customers. So you would have a centralized service. Some may call it a multi-tenant service, but at the moment we're calling it a centralized service where you would still be using VMware Cloud Foundation as a base foundation for your sovereign cloud environment, and you may be hosting multiple customers in that sovereign cloud boundary. So we would want to then offer you the ability to deploy one set of appliances that can manage multiple customers. But a question may come up, John, what happens when the provider is really managing those appliances? Can they get into the customer's keys and information?
Absolutely not. So to just illustrate that a little further, as Corey was noting there, each of those blue boxes represent a different customer that has been provisioned within a given VMware cloud provider sovereign boundary, right? But in this case, the provider is actually offering the Fortanix service as a shared service across customer accounts, but redundant across data center installations. However, what is really a great comfort to customers is that the particular key material, the account data, the details of the crypto policy that's being established is entirely private and within the control of each customer. There's very strong cryptographic and hardware enforced isolation of that material. So from the perspective of the sovereign cloud provider, you could only really provision accounts and see very high level usage data for each customer, but not see anything below that level in terms of any of the secrets that are specific to the customer. And the customer would have complete custody of those, even in the event of a lawful extraction order.
Okay, great. That's good to know. So we've given you 3 use cases. One where the customer brings their own Fortanix cluster to the environment. And the second one is where you would deploy as a sovereign cloud provider that cluster for each dedicated customer. So a separate cluster for each dedicated customer. And then this third use case where you may manage the cluster itself and centralize the services offered to your sovereign cloud customers while still maintaining that separateness, that inability for their keys, their secrets to be open and visible to you. So we're really happy about that configuration ability. Well, let's take some time and talk specifically about the Fortanix Data Security Manager for VMware Sovereign Cloud. John, we're looking forward to what you have to tell us about this product.
Sure. Well, just in this section, the three things we're going to address is how do we encrypt those sensitive workloads within this architecture on VMware? And secondly, how does this help customers stay compliant with the highest levels of certification requirements and privacy regulations and avoid those increasingly harsh penalties that are being meted out by GDPR and other entities? And thirdly is how can the customers take complete control of their own keys and crypto policies within a sovereign cloud deployment? So just to start off with, really, what Corey and I really want to illustrate is that key management is really the effective control that you have from the perspective of offering a very secure and compliant data management strategy, data security strategy. So in the case of confidentiality, we're really talking about the confidentiality of both keys and secrets and all of the settings and policies that a customer is choosing to implement that is private even from their cloud provider. And secondly, authentication really has to do with whether they be certificates or API keys, any of the authentication mechanisms that are supported, a trusted CA, a JSON web token, that there is a very strong authentication backing up how any given application or database authenticates to the key management server. And thirdly, integrity has to do with immutability of audit logs so that there's tamper-proof credibility there, that you can tell who has done what. And the principle of non-repudiation is throughout this sort of architecture, which is really the statement that means you can prove who has used what keys for what purpose, right? That's a very central tenet of audits that you need to undertake. And lastly, we use this word compliance a lot, and it means one thing in the context of data privacy regulations, but specifically in the case of a hardware security module, or what we refer to as an HSM, the National Institute of Standards and Technology has established a rating system for how secure these things can be. And the latest one that is prominently used in the industry is called FIPS, FIPS 140-2. Level 3, and you can only get to level 3 by using hardware-backed security. So when a hardware device generates a key, it has a higher level of entropy, it has a hardened level of security, so it's better. Now, this is being replaced gradually over the next few years by a new evolution of FIPS called 140-2, but of course we'll be providing you with those updates as they evolve as well. So the point here just being that really your compliance mandates are what compels us to implement encryption, but of course the world is becoming increasingly harsh with a lot of threats and advanced persistent threats out there. So the need to manage keys effectively with crypto policies and other best practices is a very high need.
So that's really great to know. And my question really around that compliance piece is, how are you able to help us ensure that compliance that we need to follow?
Right. Well, so this particular configuration has been hardened and is used to protect, some of the most sensitive financial, banking, and healthcare data lakes in the world. And we've also got extensive experience working with VMware to make sure that the critical workloads on VMware all can be past the most aggressive forms of audit and compliance assessment for that are out there.
Oh, that's great.
So just very quickly, the principles in general that are illustrated in, if any of you have had the chance to read some of the data protection orders from the European Data Protection Board, not too long ago, statements from governments on data privacy were just incredibly vague and kind of hand wavy. But now they're getting incredibly specific, and they actually talk about the strength of keys and all kinds of stuff. But to just boil it down to you, to a few key principles, the first one is really pseudonymization. And this has to do with just the matter of, really storing and processing data in a way that cannot be used to access a personally identifiable attributes of an individual. So it could be, geolocation data, it could be behavioral targeting data, anything like that. Secondly, encryption, obviously a strong encryption, as we've discussed, and you have a very vast array of different algorithms you can choose from and different policies, and you can use best practices like key rotation and quorum management and so forth. And thirdly is that the data exporter needs to be in sole control of the keys. In the case of the EU regulations, it's within the European Economic Area, but there are very similar regulations that are all around the world now. Australia has their own, Singapore has their own. There's one specifically for the nation of India, and even US states are, New York and California in particular, are leading the way here. So you can really differentiate your offering by allowing customers to comply with this, which is much better than storing just everything in, let's say, a US-based sort of hyperscaler cloud. So here we'll just take a quick minute to kind of illustrate the difference between data masking and tokenization. These are both forms of pseudonymization, but data masking is really, if you imagine kind of a call center scenario where, they're storing literally, let's say, your whole social security number, but the agent is not allowed to see anything but the last 4 digits. And you call up and they ask you, hey, what's the last 4 digits of your social security? And you read it back to them. So data masking is better than nothing, but it still really leaves a data subject to potential insider threats where the data itself is being stored in clear text, and you can have role-based access control sort of misfires where the wrong people see data they shouldn't see. And the color of the keys really is just illustrating that you don't have to apply the same policies to each particular element of the schema. So you can treat some of them differently. On the right, you have data tokenization, right? And in the case of data tokenization, the data itself is modified and replaced with a token. That token has no extrinsic or exploitable meaning or value. It's completely not cipherable, right? And this is far more secure, and this leaves you with a strong ability to attest in an audit to how you're protecting customers' data, implementing this level of encryption, right? So on this slide, we're really just illustrating that. Let's start on the right, where you really have this gray box up here, which is the third-party key management server. This is actually your Fortanix installation that is managing your keys in the VMware platform. And this allows you to conform to the highest levels of what we call crypto agility, which is the ability to implement different algorithms, different policies for different types of data. And so what you see here is within the vSphere, you have the scope of your encryption can be the whole VM, or it can be select files. But in any case, your keys are not being placed with the data. That's a big no-no on the compliance algorithms, right? Which is you definitely want to separate out those keys from where this data is being stored. And for your vSAN, your enterprise storage virtualization, you can encrypt the whole vSAN volume, but you also get encryption in flight. So the data is protected through its life cycle. This is optimal for dedicated clusters. And again, you are taking advantage of storing those keys externally. We also have configurations that for a Tanzu deployment, we have encryption for both Greenplum and SQL data at every level of granularity, whether it be database, table, row, or column.
So John, you mentioned that the keys are stored with the appliance, which is good, but what if we lose the appliance? What can we do there?
Right. So that's why we always have a triple redundancy, right? With those, every configuration is inherently fault tolerant and highly available, not only within different appliances, but even spread across different data centers. So as Corey and I showed before with the deployment architecture diagrams, is you really always have the regional redundancy built into the configuration. So next, what we have here is really just a quick high level description of the offerings that are available to you in terms of just, you know, your foundational things. We talked about customer controlled keys. We talked about VMware encryption and vSAN encryption. Sometimes you'll hear the term HSM as a service. What does that mean? It means that with a traditional hardware security module, you have to manage a lot of primitives. You have to be aware of how many keys you can fit in each partition and how many slots you have. And you have to be able to kind of interact with the fundamental primitives, if you will, of the hardware device. But in the case of the Fortanix offering, it's really truly as a service. That means there's modern APIs that are available to you, and also a great, very consumerized UI where it kind of looks like a modern banking app or something. It's very not intuitive. If you're not a crypto expert, you can create groups, you can create apps, you can encrypt data from a very friendly kind of interface. So we take care of the interaction of those commands or those policies with the, you know, the primitives of the HSM. You don't have to worry about that. And then when we hear the term BYOK, it means bring your own keys. So in other words, you're in complete custody and control of your keys for all of your data in the sovereign cloud boundary. And at the bottom, we just talk about how we have, you know, secrets management available, as well as database encryption for really all manner of data being run on VMware. So whether it be on cloud or premise, you know, things like SQL Server, MongoDB, MySQL, Postgres, Oracle, all of the data that you want to keep on a VMware environment can be encrypted with database encryption. And lastly, tokenization, which we covered for your databases, is available as well. So really here, what we're showing in this diagram is really just for high availability. You see that those Fortanix boxes are spread across different data centers, and they're highly available. And you know, that we want to ensure you that, you know, Fortanix is a certified solution for vSphere or vSAN encryption. This bit in the middle is just really illustrating a very industry standard protocol is being used called the KMIP protocol to talk to those databases and workloads. And you can use a very modern set of APIs as well from an application perspective to accomplish any of the crypto operations. So there's RESTful APIs, something called PKCS11, KMIP, JCE, Microsoft CAPI, or Microsoft CNG. They're all available for you. So you don't have any sort of odd proprietary or limited means of working with your data. And then moving on here, what we're illustrating is really that you're seeing on the right this purple box with the key in it. So you're seeing a term data security manager. And where we've talked about HSMs or hardware security modules, DSM is really just the abstraction or the control plane software that runs on top of that, that lets you interact with it, quote, as a service, right? So DSM is really just the app that is implicitly just there for you to do administration, set policies, set your role-based access control, read the logs. You can export them to, you know, syslog, Splunk, Stackdriver, whatever you like. And we're illustrating that the data is always encrypted through its entire life cycle. So at rest, you're seeing on the left, the apps, the VMs, and the vSAN instances. You see those keys. We're always encrypting those workloads. In the middle, you're seeing through the KMIP protocol, the data is encrypted in motion. So using protocols like TLS or SSL, and they're always authenticated through strong auth as well. So lastly, you say, well, that's great, but what about, isn't the data actually visible if the machine is compromised when it's in use, right? Well, we're using a very unique technology here called confidential computing, and it's based on Intel SGX technology, which establishes a trusted execution environment within the processor as well, where data is completely encrypted as it's actually being processed. So even if you were to do a memory scrape on that box while the keys are actually decrypting data, you can be assured that it is never readable to even if your infrastructure were, for example, compromised.
And hey, John, I just had one quick question. On that box, that appliance, we're really worried about the accessibility. So if there was a call by the authorities to get some of the data, I mean, of course, the encryption that you spoke about is fantastic because that really builds a nice level of trust. But what happens, as a cloud provider, am I going to be liable if I'm managing that appliance to hand those boxes over with that data?
Right. So even a cloud provider that is offering this service would have no ability to respond to an extraction order because the key material is only available to the customer who's actually secured it. So that is an additional layer of comfort. And then, of course, we know that with the sovereign cloud boundaries, the jurisdiction of control that is relevant has been deliberately determined as part of the deployment. So, this really isolates the key material from the data, and also makes sure that even the cloud hosting provider doesn't have anything to do with the data, or no availability of the keys.
Oh, that's great to know. Thanks.
And then just to wrap up, this is kind of summarizing here a little bit. If a cloud provider has provisioned some of these instances of Fortanix Data Security Manager, there's really quick time to value. You can actually set up a new account in 2 minutes for a customer and turn over to them further administration of details like what keys do they want to create, what policies do they want to have, what users do they want to use to administer the service. And then secondly, greater controls over keys. So if you're if the customer is under ransomware or cyber attack, they can use what's called a kill switch function of turning the keys off while they're in that mode, and protecting themselves until they can do an RCA. And we talked about the power of owning your own keys for your data from a customer perspective. We also have strict access control and customized role-based access control that can be established. Something very powerful is called Quorum Management. And Quorum basically means that you can establish that for sensitive cryptographic operations like delete a key or rotate a key or what have you, one administrator is not enough, because they could be a bad actor, they could be under some duress themselves. So you can set it up so that multiple administrators, let's say 3 out of 4 or 4 out of 7 administrators, have to approve a given action to safeguard data. And lastly, Corey touched on how you can meet GDPR regulations and the implications of the SREM 2 ruling on data transfers. So you have this FIP certified hardware security module, and you can rest easily that you've got the regional level of isolation that you're looking for in a solution like this.
Yeah, and I just have to say, I know for me personally, I didn't grow up in the security environment, specifically around encryption. And so talking through a lot of this and understanding how it applies to sovereign cloud seemed like it could be really complicated. But once I got into the Fortanix UI, it was really simple. The way that you guys have laid out the application itself, and the way that our customers can provide their own keys, they can import their own keys and that kind of thing. I just thought that made it really simple, the way the UI was handling that information. So really appreciate that we're able to bring Fortanix together with the sovereign cloud.
And it is really essential, right, that it is approachable by folks who are good administrators, but they're not necessarily deep cybersecurity experts, because there's a massive skills shortage. And so one of the things we want to do is arm folks to really implement powerful levels of data protection and within the system.
Yeah, that's great. All right, well, we have come to the end of our presentation, but we wanted to just kind of cover over what our top 3 takeaways were for today's session. And we wanted to make sure that you had at least a glimpse into what a sovereign cloud is. Again, that definition is constantly evolving depending on where the data resides, where the customer resides, but how important really encryption is to a sovereign cloud. without this encryption, the ability to obfuscate the data that's being transmitted to other parties, third parties, without encrypting that data in flight and at rest, or really opening ourselves up to violating that data sovereignty. And as was mentioned by John, even opening ourselves up as cloud providers to possible financial penalties as well. But then ending there with the Fortanix and how Fortanix DSM can secure your sovereign cloud offering. That's a key thing to think about as we're starting to design that cloud, whether or not you are already a sovereign cloud provider. Maybe you're looking for something much more secure and better able to provide the encryption necessary for your customers. Fortanix can definitely handle that for you, but also how we can manage our customers' security for them, ensuring that data sovereignty. And Fortanix definitely does that job for us. And then, of course, a call to action, just a quick call to action here. If you are already a sovereign cloud provider, but you want to learn more, we'd love to direct you to the via.vmw.com/SOV to learn more about it. Or if you're looking to become a sovereign cloud provider, you can definitely go to this site as well. And also please reach out to your customer account team, as they can help you learn how to become that sovereign cloud provider. And then for Fortanix, we want to make sure you know where to go to get the information on this Fortanix DSM and how it can be applied in your sovereign cloud, how it can help you to ensure that data privacy and that data security there at fortanix.com/VCPP. Well, we'd like to thank all of you. Thank you, John, so much for spending the time here today with me. And we really hope and look forward to any comments or questions you might have around securing your data in your sovereign cloud.
Thanks for attending. Keep safe out there.